Hello my friend, this session is on inequations questions based on the concept of modulus. So modulus, what it does for you is it converts the value inside it to the absolute value. So mod of -2 is 2, mod of 2 is 2, mod of -1.2 would be 1.2. It just removes the sign and gives you the absolute value as the output. So with this groundwork done, let's get down to learning by examples straight away. A warm-up question for you, something quite straightforward. A cube is equal to B cube. So now the first thing that Modulus teaches you is that whenever you see the sign, you must look at the positive case as well as the negative case. So if A cube is equal to B cube, it could have been 2 cube is equal to 2 cube, or it could have been -2 cube is equal to -2 cube. A and B are going to be equal, but they could be positive as well as negative. This case won't apply in the case when the two numbers are negative. This won't apply when the two numbers are positive, and therefore the only statement that applies in both the cases is the third statement, and therefore the right answer choice is option C. An easy question now. Look at this, 38 minus 5x, mod of this. Now this question teaches you something. If at all you got the answer is option 3, that's not correct. Sometimes looking at such easy questions, we can just go very careless and commit these questions wrong. Remember, they are very injurious because the software does not know that it was a careless mistake. The software thinks that the student could not get such an easy question right. So no, the answer is not 3. The answer is 38 minus 5 into 8 will give you 40. Mod of -2 would give you 2. The right answer choice here is option C, 2. One more easy question here. This is a favorite GMAT type. They very often ask you one question based on the number line, something like this. And the tip that I will give you is that you can just use the answer choices to your benefit. Rather than solving each of them and seeing which of them actually apply, a smarter way would be to look at these extreme values and put them in the inequation. Remember, the tip I'm giving you is that when you put the extreme values in the inequation, the left hand side and the right hand side must become equal. So if I put -1 here, -1 minus 3 becomes -4, mod of which becomes 4. 4 and 2 are not equal, therefore this statement is not going to be right. Now apply this one, 3 minus -1, so that becomes 4. So see, 4 and 4, they are matching, therefore there is a chance that this option may be correct. However, don't conclude right now. Also put the other extreme value. Put 5 here. 5 minus 3 is 2. 2 and 4 not equal, therefore this is also not going to be the correct answer choice. Look at this, -1 minus 2 is -3, mod of which is 3. 3 and 3 equal. Let's put the other extreme value, 5. 5 minus 2 is 3. 3 and 3 equal. So yes, it worked in both the cases. There is always a unique pair that works. There isn't another pair that would work on both the extremes, and therefore you can try for option D and E. They won't work. There has to be a unique pair. So the moment you get one, you need not look further. The right answer is going to be option C only. Let's increase the difficulty here, a medium difficulty level question. And this is where I would teach you how to solve these questions mathematically. So far I've been applying tricks. This is where we get down to hardcore mathematics. So if mod of x plus 3 is greater than 10, one case is that x plus 3 is greater than 10. But do not forget the other case. The other case is that x plus 3 becomes smaller than -10. Imagine if the value of x plus 3 becomes -11, then mod of -11 would become 11, which would be greater than 10. So there is another set of values for which this inequation would hold, and therefore there have to be two separate ranges. This gives you x is greater than 7. This gives you x is less than -13. The answer is not x is greater than 7. The answer is not x is less than -13. The answer is a combination of these two. One more question here. Try pausing the video and doing it yourself. So this is the other case where you have less than sign. So x minus 2 being less than x plus 1. Let me explain this through a simpler example first. So if you had something like this, x minus 1 is less than 2. So see, this means that x minus 1 has to be less than 2, but it cannot be so less that it becomes smaller than minus 2. For example, if x minus 1 becomes negative 3, then mod of x minus 1 will become 3, which would no longer be less than 2. So x minus 1 has to be less than 2, but at the same time it has to be greater than minus 2. Very important concept, do not forget this. And therefore same thing here, x minus 2 has to be less than x plus 1, but at the same time it has to be greater than the negative of x plus 1, which would be negative x minus 1. And now if you look at this closely, you will see that this inequation will not give you any result. Here x's would get cancelled. 1 is always greater than minus 2, so no change here, and therefore the answer is going to depend on only this part. Let's get all the x's on one side. Minus x comes here, so we get 2x. Minus 2 comes here, you get 1, and therefore we get x is greater than half. The right answer is option B. Look at this one here. A times b minus c, and since these are all positive values, I can take a out, a times mod of b minus c, and again since these are positive values, this operation is not otherwise valid in inequations. Imagine 2 and 3, now, but if I apply minus 1 into this, now this inequation has to reverse. So the values otherwise you see are minus 2 and minus 3. Minus 2 is greater than minus 3, but if I cancel minus 1, we suddenly will get 2 is greater than 3, which is not correct. That is why in inequations, cross multiplication or cancellation is not a valid option, but it has been given that these are all positive values, and therefore I can take the liberty of cancelling these, and therefore it boils down to b minus c less than mod of b minus c. And therefore the answer depends on the relationship between b and c. Statement 1 is not going to be sufficient. It doesn't talk about b, talks about only a and c. A has anyway gone out of the equation. It comes down to these two. B is greater than c. If b is greater than c, this becomes something positive. This also becomes the same positive value, the mod of which does no change, remains the same positive value, and therefore the two values are equal to. The answer is no, one is not less than the other, but remember it's it's data sufficiency, and no is very much an answer. Statement 2 gives you an answer. No, answer is option B. Look at this question here now. It's a difficult question. Is x greater than 0? So let's look at this one the same way. X plus 2 has to be less than 3 minus x, and it has to be greater than x minus 3. On this side you can see the two x's will get cancelled. 2 is always greater than minus 3, so no change. It doesn't give you any answer, any range of values of x. Here this is always valid. Boils down to this part. Let's get all the x's on one side. You get minus x comes here. This becomes 2x is less than 1, and therefore x is less than half. X is less than half, but how less? If it is 0.4, you get the answer as yes. If you get minus 0.4, you get answer as no. Yes and no both are possible, therefore statement 1 is not sufficient. Look at statement 2 now. There are two possibilities. One is that 2 minus x itself is equal to 10 minus 2x. And the other possibility is that 2 minus x is equal to negative of this, which is 2x minus 10. This gives you minus 2x comes here, it becomes x, and this gives you x is equal to 8, and this gives you 3x is equal to 12, so this gives you x is equal to 4. So we get two different values of x, 8 and 4, but remember the question is not asking you what is the value of x. The question is asking you whether x is positive. Whether it's 8 or it's 4, yes, it is positive. So statement 2 is giving me yes as an answer consistently. The right answer here is option B. Hope that helped, guys. Write to me for any suggestions.